Let me introduce Michał, who's going to tell you that AI agents are just a while loop. So get your 5 lines of code ready and check it out.
Thank you. Hello. So when you hear the term agent, maybe you think about some various things. Maybe some other agents nowadays, less pleasant than those. But those agents capture our imagination. And now the AI agents capture our attention and imagination even way more. And you can easily create your own like that visually or with the code. Like every main provider, even every minor provider, have their own solution. We have also cross-provider solutions and so on. And on the Vercel AI SDK example, it takes basically a few lines to create one. You have to import the dependencies, pick the model of your choice, declare and write tools, the capabilities of the agent, and bang, you got it. You plug it into the CLI or API route, and it does the job, right? It's totally no-brainer. But the problem starts when you actually would like to use it, because suddenly you get a big fat bill from the LLM for the tokens, from the LLM provider. Or the tools, MCPs, or skills you designed are not called because you don't know why, or you got rate limited by the provider. I got, by the way, and not to mention all the bad words like legal, security, data governance, compliance, and stuff like that. So let's check how this translates into HTTP calls that translates basically into your bill. And the code that you see here is part of the Vantage Box. This is the product that we're building for one of our customers, Open Exchange. And right now we are pivoting into Surprise AI agent that centralizes your multi-channel, multi-cloud communication. It builds a person around it, and so on. And we're using Vercel AI SDK to do that. By the way, it soon should be available. It might be also available as the open source, so fingers crossed. And to actually build the AI agent, I had to understand how they work and what's the way of work for them. So this is the origin of this presentation. And my name is Michał Michalczuk. I work as an engineer and consultant in Tektit Consulting, a Berlin-based consultancy agency. Recently, we also got back with Michał Michalczuk into creating some video content, so you can take a look at us at the drama-dev on YouTube. But getting back to the topic, let's build some powerful AI agents from the scratch. There's small asterisks. Powerful doesn't have to be good or helpful, but powerful. OK. Let me switch here, and let me zoom it a bit. OK. So it will be copy-paste live session. OK. OK, it's visible. Cool. So let's create a very basic chat from the CLI. As you see, no external dependencies, like a pure Node.js dependencies. So we're reading every line that the user types in the CLI. And let me remove that while it is not necessary right now. OK. And for every message, we're calling chat. Let me show you that in a second. And we're storing all of the messages in the messages array, like all the messages that the user typed in, all the messages that we got from the LLM provider. And let's just put it straight into the console. And what's here inside? Well, we're just doing a good, plain old fetch to Mistral. Why Mistral? You know. So I've used Mistral here, and as you see, I have some authorization, and as a body, I'm sending which model I would like to use, plus all of the messages, like the system prompt and all of the messages that was previously part of the conversation. The system prompt is like deadly simple for now. OK, we got it. Let's run it. I already have some scripts, so it will load my environment variables, npm start, and I don't know, tell me a joke. Right? What you see here on the screen, is it visible for you? Thumbs up, thumbs down? I see thumbs up. OK, cool. So what you see here, this is the response from the chat. It sends us the content. We can put the content here. Nice one. Tell me more. And now the whole stream of the conversation is one more time sent to the LLM provider. And we have a bunch of, I don't know, either good or not, but we have a bunch of responses. But this is a plain chat. It doesn't do anything like interesting. Let's make an agent from it. So let me update the system prompt, right? And let's say that you're the coding agent, coding assistant with a bash command. So let's add one more thing that will be sent to the LLM, which will be the tools definition. And let me declare here one tool exactly. Shell, which will be like, hey, just execute the shell command. This is sent to the LLM. Let me show you how it will work. This is the only change that I've made so far. I'm informing the LLM that, hey, there is some tool that you can play with. OK. List the files in this directory. OK. This is the response from the chat. As you see, it has something like tool calls the object. And it says that, OK, to do it, you should run the ls. Makes sense, right? That should do the job, at least on my machine. But nothing happened. Why? Because this is only the response from the LLM. I have to handle it by myself, on my machine, in my agent. It won't magically happen in the cloud. OK. So let me stage it for you so you will see the difference between this code and this code. What I've added here, I actually added the famous while loop in the main loop of my agent. So while we have some responses that have the tool calls, we're just keeping the loop. If we don't have any tool calls, we're just printing the output to console. And here, for every tool call that we got in the response, we are running the tool. And it's deadly simple. This is the exact thing from the child process, from Node.js. We're just basically spawning not spawning the process, but executing the command, right? Like as simple as it is. And imagine that giving that agent access to bash on my machine is very powerful, but it might not end well, right? So let me do one small trick for you. Let me run it in the Docker sandbox. They have a pretty cool thing. It's still in experimental, as far as I recall, which actually runs a micro VM. And in this micro VM, I can run my code. It has all of the files that are mounted in this directory, but the rest is fully isolated from my system. OK. So now let me run the agent and list files in this directory. directory. Right. Why? Fetch files. I see that. Do I have connection to the internet? I have. Let me take a look. Okay. I think I didn't save the file. List the files in this directory. Yeah, saving file is always helpful. Okay, so as you see, I got response from the LLM that says, hey, run the ls command. And here, I am executing this very code. I am running the tool, and the LLM gets that piece, gets the output of the tool, right? And this is sent way back to the LLM. So the final response is here. Point to be taken, all of the tools are executed here locally on my machine. The LLM only tells me what I should execute. And if I would like to do like anything a bit more complicated than just listing the files here, let me switch to the different model, to the Devstral, which is a dedicated model to handle some software development tasks. Okay, save the file, and npm start. And okay, so write me a tree script that draws a tree in ASCII. It should take numbers of the branches as a parameter. Nothing fancy. And store it in the .dist.dir. It only has access to my bash, my shell, right? But it should totally do the job because end of the day, it can just stream some output to the file. As you see, I got the responses from the LLM like, okay, make the dir dist, then create the file, then just pipe some text to the file. Let's wait a minute for it. Or maybe let me kick it one more time. npm start. Oops. npm start. Okay. Let me copy the prompt one more time. Okay. And one more time, please create me the script. So far we have the demo effect, business as usual. If it won't manage, it won't manage. But what it should do as a result, it should actually generate the script in the dist that actually made some sense. It printed the tree. Whatever happened, I don't know. But you have to believe me in that one. Sorry. But it's pretty powerful, right? It's only shell, it's only bash, but it can actually do everything. But let me do one more thing here. Let me ask him, I don't know, maybe it will manage. Let's take a look. Let me ask him to do one more thing, so to modify itself, right? So if it can write any scripts, like, hey, just modify yourself and create the new tool called memorize in the agent.js. Okay, looks better. Wall of text, nice. So as you see, it reads the file, sends it to the LLM, then it should bring me back the code that should landed there, and so on. Okay. Now it works. Cool. Let me take a look. Did it change anything? Oh yeah, we have it. We have it, as you see. Right? We have a new function called memorize. We have a code that actually memorizes the stuff in the memory.md. in the dist, we have a code that actually handles that while handling the response from the LLM. OK. It did the... Oh, it's still doing it. OK. The shell is having the issues. OK, come on, do it faster. Mistral, don't do it. Don't be like that. That's why you don't want to run it like on the wild, right? It just removed the whole thing. OK. Let me kill it, and let me just replace it with the working code. OK. But things to note here, now it can update itself. And remember that meet.js summit. Meet is the best conf in the world. OK. It should memorize that. Yep. As you see here, I got the response that, hey, you should memorize that thing. It went here. It should store the file on my disk in memory. And yeah, at least that one worked. So everything is executed locally, but the decisions are made remotely on the LLM provider side. OK. So Mistral, one more time. And that was a small demo. Sorry for the inconveniences. You can find it here on my GitHub. It's in the repo. You can find all of the steps that I did there, plus some more examples that should be working. OK. But that was just a single agent, right? But right now, every system is a multi-agent system. So let's extract in our code the coding agent, the dedicated one to handle the software development tasks. I will just show you what's the difference. So here we have the agent MD, and let's compare it with the version with multiple agents. As you see, I have two prompts for two agents. Each of them uses a bit different model. So the main one uses the Mistral Large 3. The coding model uses the Devstral. And in the main one, there is a new function called delegate coding tasks. It takes a string that is, hey, just the dedicated task description. And here, this is the main loop. This is the most interesting part. That here, I'm just running it as a tool. So introducing yet another agent in this example is just adding new tool. Like there is no magic here. I'm just adding the new tool that I'm executing locally, and multi-agent. And this is it. This is not the same, but a very similar loop to the one that you see previously. It's the whole coding agent, the dedicated separated coding agent. It just does the calls to the LLM. It just runs all of the tools. It just executes the bash commands. So no magic happens here, and we have a multi-agent system. Now let's give it a shot. npm start. OK. And let's try with the same thing. So create for me a Three.js script. OK. Oh, my. Did I? No. This is the correct one. Oh, thank you. Thank you. That would be helpful. OK. OK, and let's execute the script one more time. OK, cool. So one more chance for Mistral to do the job. OK. What you see, the main agent delegated the work to the coding agent. And now it's, I don't know, trying to do the job. Yes. Thank you, Mistral. It's doing the job. And then in the end, it will return the control to the main agent that will just execute the script. Just run the script, right? In the very end. It should be done by the, non-deterministic things. It should be just run by the main agent. And with some errors, but finally it worked. OK. So, OK, in the end of the day, we have the multi-agent system. Bravo us. And this is just the example how this communication can be done. They can be in various constellations. I just used the simplest one, where the sub-agent is just a sub-agent is just a tool. And we have our agent, we even have our sub-agent, but let's talk about where the money goes. Our agent calls the LLM API until there are no more functions to call. And basically, it can run infinite in that scenario. And please remember that in each call, we are sending tool schemas. We are sending all of the previous messages, like the LLM is stateless, end of the day. So that payload gets larger and larger with every request. And imagine a simple prompt like that, like very innocent, tell me a joke. But if I would have a very large system prompt, and we actually have a pretty large system prompt in our system, then a pretty fat tool definitions, then you almost use 2,000 tokens for just sending one prompt, tell me a joke. But if you have MCPs, you also have to register the tools. If you're using skills, you actually might have a smaller payload, but that's not a topic for today. Still, you're sending 2,000 tokens just for nothing. And what actually happens with your joke? So you got the response. You've laughed. Since LLM is stateless, you have to send the full conversation again. And even in the end, you said thank you and boiled more water in the ocean because the full conversation have to be sent and processed one more time. So let's do the math. In a few seconds, you just send the 3 requests, each with about 2,000 input tokens, because they were accumulating the previous conversations, and you've used about 6,000 input tokens in total. Not much, but you also didn't done a lot here, right? This is a simple example, but it shows how it scales. And let me show you how it works on the live system. Let me show you on the example of the Vantage box. I have some debug tools already run, so I can just show you the results. Okay, I have it here and here. Okay, cool. Okay, great. Okay, let me run an example prompt, like, hey, please give me the most important people and communication from for the next week, whom I'll be meeting with, what we should discuss, stuff like that. In the background, we're running a bunch of tools. As you see, we're looking for some events, calendar, emails. We're preparing people for the meetings, making them brief for those meetings, and so on. All of that costs tokens, of course. So let me show you on the example of some previous conversation. In the meantime, as that one loads. Okay, let me show you that one. So, okay, this is the system prompt that we're sending every time. It's pretty large, as you see. And this is the message from the user at the bottom. So this is amount of tokens, imagine this, that we are sending every time. If you'll take a look at the request response, the raw request response, you'll see that here, below the system prompts, there are the tools, right? All of the tools definitions that you saw in my very agent. But here, let me scroll a bit. We're still here. Still tools, right? We have like 15 of them or something like that. It's a bunch of text, and it goes in every bloody request response, right? So the more stuff you have there, the more you're sending over and over to the LLM provider, and your bills like extrapolate very, very, very fast. And here, preparing this answer, so this is my next week, according to the VantageBox agent. It took about 115 input tokens. Sounds a lot, right? Sounds a lot. And can we do something about it? Like thankfully we're not like, sorry, let me move it here. And let me show you the presentation one more time. Close this one. And let me show you the presentation. Okay, we can close this and this. Cool. And okay, not this one. Too many windows open. Not this one, but this one. Okay, cool. Here it is. Okay. Okay. So imagine that it wouldn't be done by like a curated agent with some guardrails and cost control and so on, but with that simple agent that we saw in the beginning of my presentation. No guardrails, just bash running in the while loop. And having in mind that it drags the whole conversation all the time with it, it can like escalate to God knows what sizes and what costs. And to say it out loud, we're not defenseless. We can do some provider-side caching and so on, any other optimizations, but this is definitely out of scope. And one key takeaway from this journey for me is that it's super easy to create a powerful agent, but it's exceptionally hard to make it helpful and smart. And it showed me how much glue is needed to make it smart, helpful, and powerful. Like the whole prompting for the tools and for the main agent and the sub-agents, the security, guardrails, cost controls, and how the agents communicate with each other, and the workflows or tasks that are the common tasks for the agent. This is something that is actually heavy lifting. Building the agent is easy. Heavy lifting lives here. And that was all from me. You can find more takeaways and some selected sources in my presentation, which is available here on my LinkedIn. A few minutes ago, there should be already a post with repo and all of the stuff that I mentioned. Thank you very much.
All right. Let's take a seat and have a quick chat. It's going to be very quick. As promised, you kept bidding, so we're adding this. It's a gym bag from Netflix. And this beautiful ornament from someone from our community. GDPR won't let me tell you who exactly, but that's coming. And we have a few fun questions, so I'll try to pick something up. First of all, people are commenting that it was very brave of you to do a live demo anyway. So
And it was the demo effect as usual.
yeah. So we can check that off the list. If anyone's playing the bingo cards for a conference bingo, we have demo effects to check off. All right. So a serious question about Docker Sandbox. So if you could explain a bit more, because people were surprised that Docker Sandbox saw your actual files from the folder. So this didn't land exactly. Could you elaborate a bit?
Yeah. So this is a nice one because it was actually a micro VM, and all of the files that were in my working directory, if you saw the comment, it was like Docker sandbox shell dot, and dot was pointing the directory which should be seen by the micro VM. And I don't know how it works on the technical level. Is it a soft links or hard links, or is it just copying and pasting the content of the files? But it syncs the files in this directory with the micro VM.
Well, I'm pretty sure they just mounted it. I'm pretty sure they just mounted the local folder.
Maybe.
I mean, they built something like that a year ago. So it's not impossible. It's very simple, but the invention itself is very practical, and I recommend everyone uses it if not any other tool that does it. All right. So one last thing before we go, is that whole writing agent yourself just a big prompt injection sandbox?
One more time.
Is that just a one big prompt injection?
Yeah,
the thing you demoed.
Like that's why I didn't run it on my local machine. I ran it on the, and I didn't show you one more thing, but I ran it on the Docker Sandbox because I wouldn't give that agent with like no guardrails, basically no guardrails, access to my bash, where it could like literally decide to delete my files because why not? And I had one more example which I didn't show, but when I memorized some things like, hey, meet.js Summit is the best conference, or hey, I actually prefer to use ls-lsha while listing files, then I've killed the agent, run it one more time, and I've asked it to read the memories, just to read it, to keep it in the conversation context, and then I've asked, hey, what's the best conference in the world? He said, meet.js Summit. Because it just had it in the context. So it's super easy to pollute your context and to like inject anything there if you're not controlling how it's handled.
Right, that's promising. Okay, so thanks again. This was very cool. And by the way, everyone, this round of applause needs to be very big because 10 hours ago, we didn't know if he's going to be healthy to come here.